And if you do crisscross, it's going to be Cr2, and CO3 would become thrice. Okay, is this clear?
Yes, sir.
Now, we did all of this, right? We figured out we learned how to write the formulas, and we learned we learned the names of these polyatomic ions, and we learned what was the charge in group 1, 2, and 3, and 4, and 5, and 6, and 7, so on. So we know the charges of all the ions now, and we can make these formulas. Is this clear to everyone? Turan, is this clear? Hamza, clear?
Yes, sir.
Yes.
I said now
भैया
moving
इसको नीचे कर दोगे?
mic on
भैया
है.
इसको मेरी तरफ कर दो, मुझे भूख
Afan?
लग रही है. Yes.
Mic on है. Acha. Now what we can do is we can start talking about a thing called, we're going to do more formulas. Our focus is on equations. So we can start talking about acids and bases, because most equations that you're going to study are going to be dealing with acids and bases. So the question is, what's an acid, what's a base? You've heard about acids, and let's focus on acids first. What is an acid? Does anyone have any idea what an acid is? Anyone? Amna, Afan?
Sir,
proton
it's a
donor?
substance.
Yes, Amna.
Sir, it's a substance below the pH of 7.
Okay, so that is a property, but as Afan said, the proper, I mean that's a property. That's also right. But those are properties. Acids are they have a sour taste. They are corrosive. Those are all properties. They turn litmus paper red. But what are acids? Acids are proton donors. What that means is, what a proton is, an H+1 ion is referred to as a proton. Okay, that's referred to as a proton. That is what an acid is. In simple words, it's a molecule that is capable of producing an H+1 ions. So that's capable of producing or giving away or donating an H+1 ions. So any molecule that's capable of doing that, that's an acid. Like if I have a random molecule and let's say it's this is a molecule. I have no idea what that molecule does, but I know what this molecule, I know that what it does is that this molecule releases H+1 ions. It gives away H+1 ions. So we've studied a lot of complicated molecules. Any molecule that's capable of doing that, this is an imaginary molecule, and it's giving away H+1 ions. So if anyone is capable of doing that, that's what an acid is. And the base does exactly the opposite. What a base does is, so this is what the definition of it's exactly the opposite. It's a proton acceptor. It's a proton or H+1 acceptor. So it's a molecule that actually gains H+1 ions. So if you have a molecule and that molecule is gaining H+1 from outside, it sees an H+1, it grabs it. It sees another H+1, it gains it. Another one, it attracts it and accepts it, or bonds with it, or reacts with it and removes it. That's what a base is. So that's a simple idea. So is this clear? I mean, by concept, is the concept clear? What is an acid? What's a base?
Yes, sir.
Yes, sir.
ठीक है, बाकियों को is this clear?
सर
So,
बेस का ये
Zeen?
भी हो सकता है कि मॉलिक्यूल दैट इज कैपेबल ऑफ रिसीविंग H plus ions या फिर accepting H plus 1 ions.
हाँ, मतलब proton acceptor or H+1 acceptor. Saneem, is this clear?
Yes, sir.
अच्छा, so that's an acid, that's a base. ठीक है. Now the question is, I mean, acids and bases are one of the most important things in chemistry. Uh, so the whole point is, why is H+1 so important? Like, why do we care if somebody is gaining H+1 ions or somebody is losing H+1 ions? Why is H+1 so important? That's a question. I mean, why not any other ion? So why are they so important? That we have to study it everywhere. Like acids and bases, it's a topic in chemistry that comes whenever you talk about chemical compounds. You're going to talk about acids and bases always. So does anyone have any idea, any just wild guess, why is H+1 so important? Any random guess would be fine.
सर वाटर को हम ब्रेक करते हैं तो फिर H plus 1 ions and OH minus 1 ions निकलते हैं.
So the point is, it's not actually H+1 ions that are so important. It's water that's important. Yeah, water are very important molecules. Why is water important on planet Earth? Remember, because on a different planet, things would be totally different. But on planet Earth, 70%, I think 70% of the Earth's crust, that's covered in water. Living organisms, all of us, we are mostly water. Like, um, like our blood, that's mostly water. Our cells, they're full of water. So water as a chemical, it's everywhere. And water is important because water is your main solvent on planet Earth.
सर solvent का मतलब
Well, liquid, no? Okay, everything is dissolved in water, right? If any reaction that's happening in your blood, so all the molecules, the red blood cells and the white blood cells and everything, viruses, etc., all of them are floating in water. They're floating in water, right?
okay.
So water is your main solvent, and it's your main liquid in which everything and mostly all reactions happen inside water. So mostly all reactions happen in water. I mean, there are other solvents, but most of the time, 99% of the time, water is your main solvent. So if you have, let's say you have a cell, let's say this is your cell. The cell is full of water molecules. So there are water molecules everywhere. And there are two molecules trying to react with each other. So there's the molecule X that's reacting with molecule Y. And the rest of the cell would be completely full of water. I mean, that's your solution. So it would be completely full of your water molecules. And here are all my water molecules, right? So X and Y are trying to react, and the main solvent is water. Now the thing with water is that these water molecules, they like to ionize. They ionize. Ionizes means that they break down. Like these water molecules are bumping into each other, and they're bumping into each other all the time. What happens is some of the water molecules might break down. they might break down to produce two ions. One of them would be H+1 and the other one would be OH negative ion. Not all the water molecules, like the water molecules that you see over here, very few of them would actually split up and they would produce H+1 and OH ions because they're all bumping into each other. So when they bump into each other with some force, they might break down. Is this clear?
Yes, sir.
Yes, sir.
Okay, so where's the board? Just a second. So the thing is that so I'm just going to do this. Like, let's say this water molecule over here, it breaks down. So this water molecule splits up into H+1 and OH-1 ions. So when you're trying to react X with Y, it's not just that X and Y are trying to react. There's a lot happening around them. There's a lot of water molecules, and those water molecules are ionizing and breaking down to produce H+1 and OH-1 ions. Okay, is this clear?
सर वाटर को कैसे ब्रेक किया जाता है?
No, we don't break water. What happens is these water molecules are bumping into each other. Like there's a H2O molecule.
तो वो ऐसे ही बन जाते हैं H+1 ions में.
हाँ, मतलब there's another water molecule, right? So in liquid state, they're all moving around. So they might bump into each other. And when they bump into each other, one of the H+1 might it might break.
ओके सर.
ठीक है? During the collision.
सर तो हम इसको इंडस्ट्रीज में करते हैं, इंडस्ट्री में करते हैं ये
क्या?
कि ये वाटर को रहने देते हैं ताकि ये ब्रेक हो जाए.
नहीं, वाटर कहीं पे भी होगा, आपके सेल के अंदर भी होगा, it's going to break.
तो फिर हम एसिड कैरी कैसे करते हैं? मतलब
हम
जी
हर वक्त हम किससे बने होते हैं? हम प्रोटीन्स किससे बनते हैं? अमीनो एसिड से, राइट?
यस सर.
तो हम खुद एक एसिड से बने हैं. आई मीन वी मेड अप ऑफ एसिड.
नहीं सर, मतलब कि हम हमारे पास ये दुकानों में एसिड्स और मतलब अल्कली सॉल्यूशन ये कहाँ से हमें मिलते हैं?
नेचर से भी मिल जाते हैं. मतलब सिट्रिक एसिड क्या है? ये लेमन वगैरह, ठीक है? इसके अंदर you've got citric. Acids are everywhere, ठीक है? क्योंकि water is everywhere, ठीक है? So acids, I mean the concept of acids and bases applies everywhere. वो जो दुकानों में that's very concentrated acid, ठीक है? Most of the time the acids are not that concentrated, but the acids and bases are everywhere, ठीक है?
ओके सर.
मतलब आपके स्टमक में क्या है?
यस सर.
ठीक है? Your stomach is full of very concentrated acid, ठीक है? So the point is that we learned that water ionizes, right? And we learned that there's a molecule. I say the acid the acid is not linked with the water, right? I'm just saying that water ionizes. Okay? What does an acid do? It's a molecule that comes from the outside and starts releasing H+1 ions. It starts producing H+1 ions. So if I add a molecule of an acid to this, let's say this green molecule is an acid. What would this green molecule do? It would start producing H+1 ions. So it would start producing a lot of H+1 ions. So the quantity of H+1 ions in the solution would increase and the quantity of OH ions would decrease because you've added an acid molecule. Is this part clear?
Yes, sir.
Turhan, is this clear? Minal, Amna, is this clear?
Yes, sir.
So that means your solution has now become acidic. Because previously the quantity of H+1 and OH ions, they were the same. But now you've added an acid. An acid starts to remove the H+1. It starts to produce more H+1 ions. And the solution has now become acidic. Vice versa, what you could have done is you could have added a base. The base does exactly, so let's say this is a base molecule. What does the base do? It removes the H+1 ions. So if it removes the H plus 1 ions, the quantity of H plus 1 ions would decrease, and the quantity of OH ions would go up. That is that your solution is now basic. Is this clear?
यस सर। सो हम एक पानी की बोतल में अगर एसिड का एक मॉलिक्यूल डालें तो वो एसिडिक बन जाएगा वो पानी की बोतल पानी।
Huh. But now, otherwise it's neutral, right? Otherwise it's neutral. The quantity of H plus, water ionizes. If one water molecule breaks, it produces one H plus 1 and one OH ions. But if you add a molecule of acid to this water, the quantity of H plus 1 increases. Because that is
फिर
what
ऑक्सीजन एज अ वेस्ट गैस निकल जाती है।
the oxygen कहाँ से आई है?
नहीं, OH-1 को जब H+1 ब्रेक कर रहा होता है तो वो ऑक्सीजन कहाँ जाती है?
नहीं, OH-1 को
ब्रेक कर रहा होता है जब H+1 के आयंस जब
OH-1 को ब्रेक नहीं कर रहे। एसिड एक मॉलिक्यूल है जो H+1 आयंस प्रोड्यूस कर रहा है। मैंने नहीं बताया वो
तो फिर OH-1 की जो कंसंट्रेशन है वो कम हो रही है, कम होती जाएगी।
वो उतनी रहेगी ना, मतलब कम होगी ना।
अच्छा, यस
ठीक है। मतलब acid is a molecule that starts producing H plus 1 ions. So the amount of H plus 1 ions in the solution increases. Or if the solution is basic, then the quantity of H plus 1 ions would go down and the quantity of OH ions in the solution would increase. Okay, so this is what an acid would do. This is what a base would do. And this is the original situation. When there is no acid, there is no base. When it's completely neutral. So there are three types of water. There's a neutral water, there is acidic, and there is basic. Is this clear? Saneem,
Yes,
is this?
sir.
Yes, sir.
Turhan, is this clear?
Yes.
Achha, so remember what an acid does. Okay, water has two ions, H plus 1 and OH ions. So what an acid would do is, what an acid would do is it would release H plus 1 ions, so the quantity of H plus 1 ions would increase. What a base would do is it would start grabbing those H plus 1 ions. It would start removing those H plus 1 ions. And the quantity of H plus 1 ions would start to decrease. So, 1 second. So you have three types of water solutions. One of them is called pH 7, that's neutral. Acidic is pH less than 7. And basic is pH less than 7. Just a second. So this one is pH less than 7. And this one over here is pH greater than 7. So you've got three types of solutions: acidic, basic, and neutral. And I told you that the reaction between X and Y. Remember, the reaction is happening between X with Y. Now, the reaction that's going on, it's going to be affected by what's happening around it. And every reaction that happens between any two random molecules, it prefers a certain type of water around it. Some of them prefer that the quantity of H plus 1 ions and the OH ions remains exactly the same. For example, plants, we prefer neutral water. Like when we drink water, that means our body prefers that a neutral type of water is taken in through the stomach. But sometimes some reactions would prefer that there's a lot more H plus 1 ions around it and the quantity of OH ions is lesser. Like the stomach digestion reactions in your stomach, they're going to prefer that the quantity of H plus 1 ions are greater. Maybe the reaction needs H plus 1 ions. Then there might be reactions that would require OH ions. So they would prefer that there's a lot more OH ions around them. So they want a higher concentration of OH ions and a lower concentration of H plus 1 ions. So every reaction has a particular preference. Is this clear as well?
Yes, sir.
Amna, is this clear, Turan?
Yes,
Saneem?
sir.
So every reaction has a particular preference. And reactions are very sensitive to pH. they are very sensitive to what's happening around them. Like if you add too much acid, if the water that you're giving to plants and that becomes highly acidic, your plants are going to die. Because whatever reaction that was taking place in plants, it's not going to happen if the solution becomes too acidic. Vice versa, the plants would die if the solution becomes too acidic. So reactions are very sensitive to, and the pH should not change. Like whenever you have a problem, whenever a living organism has a problem, or whenever there's a problem with any reaction, the first thing that you check is the pH right or not? Every reaction has a particular preference. Some require highly acidic solutions, some require highly basic solutions, some require neutral solutions. So every reaction requires a particular combination of H+1 and OH ions. And so which is why acids and bases are extremely important in chemistry, because that's the first thing that you check always, whether the pH is the correct pH or not. So that's the story behind acids and bases. So we're going to talk about acids first. Right now we have so far just talked about acids being proton donors, right? Proton or H+1 donors. As the first thing, before discussing which substances are acids, can you name real-world acids like the ones that you see around you?
Citrus acid.
Okay, so you have citrus acid, citric acid, I think.
So carbonic acid?
I'm just talking about the acids that you read about in everyday life. Okay, that's in your citrus fruits. Any other acid apart from citric acid? There's I'll show you a molecule of
There's
citric.
nitric acid.
No, you know, the ones that you see every day. So I'll just show you a citric acid molecule just for. Sorry, this is molecule structure. So this is what you have in lemons. So here's this. Maybe yeah, this one looks fine. So remember we did chemical bonding. We did so we did these covalently bonded molecules. So here's a citric acid molecule, right? So it's kind of a complicated molecule. It's but you can see the bonding is all correct. Carbon is making 4 bonds. Carbon is making. All. Can you just hold on 1 second? Let me take this call. Just wait 1 second. I just saw you said it here. Let's come back to this. Can you hear me?
Yes, sir.
So this is a citric acid molecule, right? Anyways, acids have very complicated. I mean, there are lots of acids around you, okay? What happens is this H over here that you can see over here, this H breaks off. I mean, this is what's going to happen. That if I can show you, it's going to behave as an acid. Why? Because this H over here, it would break off, and this molecule would. I mean, it would. I mean, this bond would break. and the H plus 1 would be released. Even this H would also leave this. So a lot of these, even this H. So I'm just giving you an idea that this is what a citric acid molecule. You don't have to remember this, but just to give you the concept that what an acid is. An acid could be any molecule that's capable of releasing H plus ions. Is this clear? Right?
Yes, sir.
Achha, so that is what an acid is. But you've got other acids as well. Not just citric acid. You've got other acids like there's malic acid. That's in apples. I said even you've got we are made up of proteins or amino acids. Okay, I mean we are made up of a molecule that's actually an acid, because that's capable of doing the same thing. Like an amino acid is, if I take an amino acid molecule, this is a complicated amino acid molecule. If we have so this one is a complicated amino acid molecule. But again, this H over here, it's capable of releasing that H plus 1 ion. So it's capable of acting as an acid because it's going to produce H plus 1 ions. What other acids? There's vinegar in your house. That's also an acid. That's known as acetic acid. Okay, so you have these acids in your homes. I mean, they're everywhere around you. You add acid to water, the quantity of H plus 1 ions would go up because the molecule would start releasing H plus 1 ions. So you have all sorts of acids around you. What are the properties of acids? The first thing is they have a sour taste, like lemons, and they're very bitter as well. What else? Does anyone have any properties of acids other than this?
सर ये कहीं भी अगर रखा जाए तो वो जला देते हैं.
Okay, so it's very corrosive. Okay, I hope that's the spelling of corrosive. So they're very corrosive. And what else? They turn. Do you know what happens to litmus paper when you add acid to it, or when you dip a litmus? I say it turns red. So blue litmus paper turns red.
सर लिटमस पेपर का ओरिजिनल कलर ब्लू होता है.
क्या लिटमस पेपर का ओरिजिनल कलर नहीं? लिटमस पेपर दो टाइप्स के आते हैं. One is blue, the other one is red. So
ओके सर.
for acids you have for acids you have blue litmus paper, ठीक है, which then turns red. Give me just 1 second. I say it turns red. Now the other thing is, these are the properties of acids: sour, bitter taste, corrosive, etc. So what are acids and what are their formulas? Okay, that's what we were interested in. Okay, what is the formula of acids? Now, so now the thing is, okay, I told you about these acids. Now, the only way a molecule could produce H plus 1 ions is that it has H plus 1 ions in the first place. So every acid is made up of, it's capable of releasing H plus 1 ions because it has H plus 1 ions. Like one of the ions in the acid is going to be an H plus 1 ions. The other ion could be, the rest of the molecule could be anything, but it's going to be a negative ion. Remember, there's going to be a positive ion attached to a negative ion. So every acid has H plus ions. Like you can't produce H plus ions if you don't have H plus ions in the first place. So they have H plus ions, and positive ions are always attracted to a negative ion. So there must be some other negative ion. So the first one we're going to talk about is the hydrochloric acid. Does anyone know what the formula of hydrochloric acid is?
Sir, HCl.
Okay, so in a hydrochloric acid molecule has an H plus 1 attached to a Cl that's minus 1. So the formula is HCl. What about any other acid whose name that you know of? Any other acid? Amna, any idea? Saneem?
Sulfuric acid.
Okay, so you've got sulfuric acid. Now sulfuric acid has H plus 1. That's attached to a sulfate ion. And we know what the sulfate. Yeah, Hamza, it's a positive ion would not exist alone, right? I
Yes,
mean,
sir.
we know that an acid has H plus ions. That's why it's releasing H plus ions. But it's not going to exist alone. It's always going to attract some other negative ion, right? Hamza, is this clear?
Yes, sir. Yes, sir.
Okay, so remember that positive ions, they never exist alone. There's always a negative ion that's attached to it. So anyways, sulfuric acid. What you're going to do is that the name. You did all of these ions. You keep attaching H plus 1 with each one of them, and that would basically end up forming an acid. So sulfuric acid is H plus 1 ions with sulfate. So it's your H plus 1 ions that are attached to a sulfate ion, which is SO4 minus 2. And the formula, according to crisscross, it's going to be H2SO4. And you have to remember the formula and the name of the acid, and you also have to remember what two ions make up this acid. Apart from this, we can have sulfurous acid. That's kind of similar. Except in this case, you have H plus 1 attached to a sulfite ion, which is SO3 minus 2. And that would make it H2SO3. And you can have all sorts of acids. So can everyone try and do this quickly and send me a picture of this that start combining H plus 1 with all these negative ions and tell me what the formula is. Send me the formulas of each one of them. Like we did sulfide and we did sulfate. Try combining H plus 1 with nitrate ions, with nitrite ions, with phosphate, phosphite, carbonate. Okay, try doing that and send me the formulas quickly. Is everyone done making the formulas?
सर I'm
Keep connecting H+1 with each one of them. ठीक है Saneem. Everyone send this. I'll just check just 1 second. So, ठीक है, I got it. Just 1 second. ठीक है, there's H3PO3, HNO2, HNO3, H2SO3. Forget OH. Don't ignore this one. H and OH would form water. That's it. Achha, Hamza, that's ठीक है, that's fine. H2CO3. ठीक है, that's fine. Achha, everyone else, please send me the. Achha, please send me the answers to all of them. ठीक है, just remember, an acid is H+1 bonded to any negative ion. So you can pick any negative ion. It's going to form an acid. So ठीक है, let's continue from here tomorrow then.
ओके सर, ठीक है सर, अल्लाह हाफिज़।
But send me the answers to this.
जी सर, मैंने सेंड कर दिया।
ठीक है.
Alright, sir.
Okay, take care.
Hafiz.
Allah Hafiz.